Okay, so you want to buy an aluminum smelter. $5 billion of capital, 500,000 tons of metal a year, contracts with every major industry on Earth. Automakers, aerospace, defense, packaging. Buy low, sell high. Watch the ingots roll onto ships bound for Asia and Europe. Sounds simple? It is not simple. And the story of how aluminum smelters actually make money and how they actually die is one of the strangest in modern industry. Because the business you think you're buying is not the business you're actually buying. You think you're buying a metal factory. You are not. You are buying an electricity contract. And the metal factory just happens to sit on the other end of it, glowing red hot, 24 hours a day. When that contract is cheap, you print money. When it expires and the utility says no, everything you built is worthless within 90 days. Everything. Before we go any further into why this business is fundamentally different from every other manufacturing business on Earth, you need to understand what you are actually buying. Because aluminum smelter is not one business. It is at least 4 different businesses that happen to share the same industrial silhouette from the highway. The first type is the vertically integrated major. Alcoa, Rio Tinto, and until recently Rusal owned the bauxite mines, the alumina refineries, and the smelters themselves. They control the entire chain, from red earth extracted in Guinea or Australia to finished coils, leaving a port in Iceland or Quebec, all under one balance sheet. The second type is the standalone smelter. It buys alumina on the open market and depends almost entirely on a long-term power purchase agreement to survive. Century Aluminum's Hawesville plant in Kentucky was exactly this. So was Magnitude 7, Metals in Missouri. So are dozens of plants across Europe and North America. The third type is the hydro-powered smelter. Iceland, Quebec, Norway. These plants exist because their host country has cheap, stranded hydroelectricity that cannot be exported through wires. Aluminum, in effect, becomes the export vehicle. The country sells electricity to the world in a form that fits inside a shipping container. This is why Iceland, with a population under 400,000 people, produces more aluminum per capita than any country on Earth, despite having almost no bauxite. Every ounce of raw material is shipped in from Australia, Guinea, or Brazil. Every ingot of finished aluminum is shipped back out. The country is an electricity terminal in metal form. The fourth type is the coal-tied smelter, mostly in China and India. Razor-thin margins, existing entirely because of coal subsidies and state industrial policy. China alone produces roughly 60% of the world's primary aluminum, not because of bauxite, not because of labor, because it has the cheapest coal-fired electricity on Earth. Backed by state industrial guarantees, price ceilings on power for strategic industries, and a national commitment that no smelter of strategic importance is allowed to fail. Understanding which of these 4 types you are looking at is the first thing that separates a serious buyer from a curious tourist walking through the front gate. Now, the surface economics, the part that shows up on every industry brochure and every investor deck. This is what the seller wants you to focus on. A modern smelter producing 500,000 tons per year typically occupies between 200 and 500 acres of industrial land near cheap power. The upfront capital cost to build one from scratch is $4 to $6 billion. Not 1 billion, not 2, 4 to 6, minimum in current pricing. The pot lines, long rows of electrolytic cells where alumina is turned into aluminum, run at temperatures between 950 and 1000 degrees Celsius. They operate 24 hours a day, 7 days a week, 365 days a year, for decades on end without stopping. Alumina, the white powder you feed into these cells, costs somewhere between $300 and $450 per ton on the global spot market. You need roughly 2 tons of alumina to make 1 ton of aluminum. So alumina alone is $600 to $900 per ton of finished output. Labor headcount for a full smelter runs between 400 and 1,500 people, depending on scale, automation level, and the country you are operating in. Add carbon anodes, refractories, casthouse consumables, port logistics, and shipping. All of that stacks into another few $100s per ton of aluminum produced. So, on the cost side, before we even mention electricity, you are already committed to roughly $1,000 to $1,200 per ton of finished metal. Now, the big number, the one that changes everything about how this business is structured, priced, and where on Earth it can profitably exist. A single 500,000-ton smelter consumes between 8 and 10 billion kilowatt hours of electricity every single year, without exception, without pause, without holiday. To put that in physical terms, that is roughly the entire annual electricity consumption of the state of Rhode Island. One factory, one state's worth of power. To put it in corporate terms, That is roughly 100 times the annual electricity draw of a large Amazon or Google data center. Every year. Read that again. One industrial plant in one small town, consuming as much electricity as an entire state of 1 million people, continuously, forever. Which brings us to the single most dangerous structural fact about this business. The one that most first-time buyers discover only after they have already signed. You are not allowed to turn a smelter off. Not really. Not the way you can shut down a car plant for a long weekend. Compare it to a steel mill. A steel plant can idle a blast furnace for weeks at a time. A car plant can shut down for the summer. A refinery can be throttled up and down. A cement kiln can be banked. Almost every heavy industrial process has some kind of graceful pause button available. An aluminum smelter does not. Once you have started the current flowing through those cells, you are committed to keeping it flowing for the entire life of the plant. If the pot lines cool below a certain temperature, the alumina inside them literally freezes into solid stone within the cell walls. The molten cryolite bath, which normally floats above the liquid metal at nearly 1,000 degrees, hardens into rock inside every single cell in the pot line. Restarting a frozen smelter is not a matter of turning it back on. It is a matter of drilling out the cells with jackhammers, one by one. Rebuilding them takes anywhere from 6 to 12 months, and the cost of a full restart can easily exceed $500 million, sometimes more. Which is why smelter owners will sometimes keep a plant running at a large monthly loss for months, hoping the electricity market swings back before they have to make the cut. They are not being stubborn. They are choosing which death to die. Slow, controlled bleeding versus fast, permanent, irreversible extinction. That is not a factory. That is a heartbeat that cannot be paused, wired directly to a power grid that has every incentive to charge more the longer you stay connected. Now we get to the part of this business that actually explains everything else. Everything you are about to learn is downstream from what I am about to show you. Every ton of primary aluminum produced anywhere in the world requires between 14,000 and 15,000 kilowatt hours of electricity. This is a physics constant, not a market condition. The Hall-Héroult electrolytic process has not fundamentally changed since 1886. 15,000 kilowatt hours per ton. There is no efficiency improvement, no clever engineering, no new catalyst that will meaningfully change that number in your lifetime or your children's lifetime. So let's do the math that every actual smelter owner in the world runs every single morning before their first cup of coffee. If your electricity contract locks you in at 3 cents per kilowatt hour, your electricity cost per ton of aluminum is roughly $400 to $450. If your contract runs at 8 cents per kilowatt hour, closer to the residential rate in most American states, that same electricity cost is now $1,100 to $1,200 per ton. Same plant, same equipment, same workers, same tons of aluminum coming out the other end. The only variable is the number printed on your utility invoice. Now, look at your revenue side. A ton of primary aluminum cells on the London Metal Exchange at somewhere between $2,000 and $3,400, depending on the year. Let's take a mid-cycle price of $2,400 per ton. That is your revenue per ton of finished metal, before any other cost, before any tax, before anything. On the cheap electricity plant, after paying for power and everything else, you have roughly $600 to $800 of margin per ton to work with. On the expensive electricity plant, that margin has been eaten alive. You are barely breaking even, or you are losing money on every single ton you produce. The difference between one plant printing money and another plant hemorrhaging cash comes down to about 5 cents per kilowatt hour of electricity. That is the entire business. Read that again. Everything else, the pot lines, the workers, the port, the alumina contracts, the aluminum coils, rolling out the loading dock, none of that determines profitability. All of that is theater. Impressive, capital-intensive theater. But it is theater built around one single input that determines whether the whole show makes money or not. On paper, aluminum smelters sell metal. In reality, they sell electricity in a shape you can stack on a boat and export to places that do not have cheap power. This is why I keep calling aluminum frozen electricity, because that is quite literally what it is, at an economic level. Every ton of aluminum that leaves a smelter contains embedded in its atomic structure 15,000 kilowatt hours of past electricity converted into a portable, tradable form. You cannot ship electricity across an ocean through a wire. High-voltage lines lose too much energy over distance. There is no practical transatlantic power cable, but you can ship aluminum across an ocean very easily, in enormous quantities, on slow, cheap bulk carriers at costs of a few dollars per ton. So countries that have huge amounts of cheap electricity, and no way to export it directly, use aluminum smelting as their electricity export terminal. This is not a metaphor. This is the actual business model. Ask anyone who has built a smelter in Iceland, in the United Arab Emirates, in Bahrain, in Mozambique. Iceland has almost zero domestic industrial demand for electricity. It has enormous amounts of hydroelectric and geothermal power sitting in an island grid disconnected from Europe. So Iceland exports its electricity, not as electrons through a cable, as aluminum on a boat, in ingots that get melted down into car parts and beverage cans on other continents. The United Arab Emirates does exactly the same thing with cheap natural gas. Emirates Global Aluminum is one of the largest smelters in the world, powered almost entirely by domestic gas turbines. Why? Because the Emirates can burn its own gas to generate cheap electricity and then export that electricity as metal, rather than trying to sell the gas as LNG at world prices. Bahrain, same story. Mozambique, same story. Quebec smelters, same story, powered by Hydro-Quebec's massive dam network. All of them are electricity export terminals. None of this is decoration. None of this is legacy industrial location. This is the entire business model, made explicit if you know where to look. Now here is where it gets structurally dangerous, and where every smelter owner in a country without cheap trapped electricity discovers the trap. The way you get access to cheap electricity in a country like the United States is through a power purchase agreement, signed with a utility, typically for 20 to 30 years. The utility agrees to sell you power at a specific rate, well below the market price for residential or commercial customers, in exchange for you providing steady, predictable baseload demand. That baseload demand is genuinely valuable to a utility. Aluminum smelters run flat, 24/7, 365, forever. They are the perfect grid customer, at least on paper. They help the utility justify its own capital investments in power plants and transmission. They stabilize the grid. They pay predictable, huge monthly checks. Everyone wins. Initially, but contracts expire. And when a 25-year PPA hits its final year, both sides look at the same question with very different answers. The smelter owner asks, will they renew me at something close to my old rate? Because if not, I am dead within a year. The utility asks, why exactly would I renew you at 3 cents per kilowatt hour when I could be selling that same electricity to residential customers for 9 cents? The utility does not need you the way you need the utility. And in most cases, that answer becomes very clear, very quickly, when the contract comes up for renewal. Why would anyone build an aluminum smelter in Iceland, a country with essentially no bauxite of its own? The answer is not aluminum. The answer is electricity that has nowhere else to go. Why does no one build a new commercial smelter in the mainland United States anymore, despite the country having massive aluminum demand and mature infrastructure? Same answer. American electricity has too many other customers willing to pay more. Aluminum smelters simply cannot outbid data centers, EV factories, and residential heat pumps for grid power. This is the structural fact that drives the geography of the entire global industry, and it explains almost every smelter opening and closure of the last 30 years. Cheap, stranded, subsidized, or state-guaranteed electricity attracts smelters. Everywhere that electricity has other, higher-value customers, smelters die. It is that simple, and it is that brutal. None of this is decoration. This is the entire business model, hidden behind the industrial photography of glowing potlines and molten metal pores. The metal is the exhaust. The electricity contract is the engine. And every serious buyer of a smelter understands this before they sign anything. To see how completely electricity controls this business, you do not need to build a spreadsheet or read an industry report. You just need to look at Hawesville, Kentucky. In the summer of 1969, a company called National Southwire Aluminum broke ground on a smelter on the banks of the Ohio River in western Kentucky. The site was chosen for one reason above all others. The Tennessee Valley Authority, one of the largest publicly owned utilities in America, could deliver electricity at a rate no private utility could match. That plant, later acquired by Century Aluminum, operated continuously for 53 years. It employed just over 600 workers at its peak, in a county with fewer than 80,000 residents. It produced roughly 250,000 tons of primary aluminum every single year. That output was not decorative. It was strategic. Century Hawesville was the only smelter in North America that produced high-purity aluminum used for armor plating on American military vehicles. Roughly 40% of the aluminum going into United States defense contracts, from tank hulls to aircraft structural components, passed through the Hawesville potlines at some point. This was not a marginal industrial facility. This was a piece of strategic national infrastructure, quietly humming on the edge of a small Kentucky town for over half a century. And then, in the summer of 2022, it stopped. Suddenly, almost overnight, because of a single input on its cost sheet. The trigger was Europe. In early 2022, natural gas prices in Europe exploded, driven by the war in Ukraine and the collapse of Russian gas supply to Germany and beyond. European aluminum smelters, most of which run on gas-fired electricity, started shutting down. And European utilities began pulling every ounce of natural gas they could from the global market. That global gas demand pulled American natural gas prices up sharply, which pulled American wholesale electricity prices up with them, especially in gas-heavy grids like Kentucky's. Wholesale electricity in Kentucky, which had traded around $40 per megawatt hour for years, roughly doubled to about $85 per megawatt hour within 12 months. For Century Hawesville, that math was fatal. On a plant consuming several billion kilowatt hours of electricity per year, doubling the power price added hundreds of millions of dollars of annual cost. Century's aluminum revenue could not stretch to cover it. There was no way to raise prices. LME aluminum trades on a global commodity market, indifferent to what one Kentucky plant pays for power. In March of 2022, Century began sending warning letters to the Kentucky Public Service Commission. In May, the plant announced curtailment. In June, it fully idled. 628 workers, most of them second and third generation Hawesville employees, were laid off within a matter of weeks. The town's largest single employer was gone. Not gone in the sense of a slow decline. Gone in the sense of a factory that lit pot lines during the moon landing going dark before Halloween. The plant that had produced military-grade aluminum for 53 years was killed not by a competitor, not by China, not by demand collapse, not by a strike, not by a scandal. It was killed by a line item on a utility bill. One number, one line. That is all it took to end 53 years of continuous production. The federal government, recognizing the strategic loss, later announced roughly $500 million in aid through the Department of Energy's Industrial Demonstration Program in 2024. As of now, in mid-2026, the Hawesville plant has still not restarted. The pot lines have been cold for 4 years. The alumina inside them is stone. The restart, if it ever happens, will cost several $100 million on its own and require a new long-term power contract at a price that no utility is willing to write. And this is not a Kentucky story. This is not a Century aluminum story. This is the story of nearly every standalone aluminum smelter in the developed world since about 2020. In 2020, Alcoa idled its Intalco smelter in Ferndale, Washington, laying off about 700 workers. The trigger was the Bonneville Power Administration, ending its favorable contract terms. Same structural mechanism. A utility, this time federal, decided that its cheap hydro was worth more sold to other customers than to a metals plant paying 1980s rates. Alcoa fought it. It appealed. It lobbied. It ran press campaigns about jobs and strategic industry. It lost. The plant is still idled. The pot lines are cold. In late 2021 and into 2022, Aluminium Dunkerque in France, the largest smelter in Europe, cut its output by 22% within a single quarter. The reason was simple. European wholesale electricity prices had spiked above €600 per megawatt hour, roughly 10 times normal. No amount of aluminum revenue could absorb that. Slovalco in Slovakia, Alro in Romania, Trimet in Germany, Talum in Slovenia, all curtailed or fully closed within the same 18-month window, for the same reason. None of these plants were badly managed. None of them made bad aluminum. None of them lost their customers. All of them just lost their electricity. This is not an accident. This is the business model. When your economics are entirely controlled by one input you do not produce and do not own, this is exactly what happens. The Century aluminum shutdown at Hawesville is not a warning. It is not a cautionary tale. It is a demonstration of the underlying physics of this entire industry. Every aluminum smelter, everywhere on Earth, is one contract renewal away from becoming Hawesville. Every single one. The only question is when their contract comes up. So what does all of this actually look like on a spreadsheet? Let's put two numbers side by side. Same plant, same everything. Different power price. Scenario A. This is the dream scenario. This is what the aluminum industry looked like for most of the 2010s, from roughly 2010 through 2020. Your plant produces 500,000 tons of primary aluminum per year. LME aluminum trades at an average of $2,400 per ton across the cycle. Revenue equals 500,000 tons, multiplied by $2,400 per ton. $1.2 billion in annual gross revenue. That is the top line. Your electricity contract, signed 20 years ago with a favorable utility, delivers power at 3 cents per kilowatt hour. Your plant consumes 7 billion kilowatt hours per year at that rate. Your annual electricity bill is $210 million. That is a huge check to write, but at 3 cents per kilowatt hour, it is manageable. Alumina, at 2 tons per ton of aluminum output, at roughly $400 per ton, costs you another $400 million per year. Labor, at say 1,000 workers at loaded cost of $100,000 each, is another $100 million. Maintenance, consumables, logistics, another $150 million. Total operating cost, roughly $860 million per year, against revenue of $1.2 billion. That leaves you with a gross margin of about $340 million. EBITDA of roughly $340 million. On a plant that cost you $4 to $6 billion to build, that is a payback in the neighborhood of 15 years. Not exciting, but respectable. Steady. Predictable. This is the aluminum smelter business that industrial history books get written about. This is the version investors and communities love. Now scenario B. Same plant, same workers, same customers, same alumina supplier, same LME price of $2,400 per ton. Nothing physical has changed. Your PPA has just expired. And the utility has offered you a new contract at 8 cents per kilowatt hour, closer to what industrial customers now pay across America. Same 7 billion kilowatt hours of consumption. But your electricity bill has just gone from $210 million to $560 million per year. A $350 million increase in your annual cost base. On a plant whose entire gross margin used to be $340 million. Your EBITDA has just moved from positive $340 million to negative $10 million. Your plant is now losing money every day on every ton it produces. And this is not something you can fix with better management. This is not something a new CEO can solve. This is not something a productivity consultant can save. There is no operational lever, no lean manufacturing program, no automation project that can offset $350 million of additional annual electricity cost. It is not possible. You cannot cut your way out of that. Even firing every single one of your 1,000 workers would only save you $100 million. You would still be losing money, and you cannot cut your electricity use. 15,000 kilowatt hours per ton is a physics constant. You cannot innovate around it, cannot conserve around it, cannot design around it. You have exactly two choices once you find yourself in scenario B. You can run the plant at a loss, slowly bleeding cash while hoping electricity prices reverse. Or you can idle the plant, take the write-down, lose the workforce, and watch the pot lines freeze into stone. Neither option is good. Both options are structural, not operational. That is not manufacturing risk. That is regulatory risk. That is monetary policy risk. That is geopolitical risk. Dressed in a hard hat, standing on a factory floor, which brings us to the most important structural insight in this entire industry. It is the one that determines where new smelters actually get built in the 21st century. Nobody with any experience in this industry buys or builds an aluminum smelter thinking about aluminum. That is the wrong analytical frame. That is amateur thinking. What they buy, what they are actually paying for, is guaranteed long-term, subsidized access to cheap electricity in a jurisdiction that will not renegotiate the deal for at least 20 years. The aluminum plant is just the vehicle for capturing the economic value of that electricity access, converting it into a portable, tradable, exportable form. This is why every new smelter announcement in the last decade has been in Saudi Arabia, in the UAE, in Malaysia, in Indonesia, in Kazakhstan, in Guinea, in Mozambique. All of them are jurisdictions where the state guarantees electricity at prices well below any market clearing rate, sometimes for 30 or even 50 years, backed by sovereign commitments. That is what a buyer of a smelter is really buying. Not aluminum production. Sovereign guaranteed cheap electricity, wrapped in a metals facility, exported as ingots. Owning an aluminum smelter is a lot like renting a football stadium for a professional team. The grass is not the business. The lease on the stadium is, and the day the stadium owner decides not to renew your lease or triples your rent, you do not have a football team anymore. You have a very expensive lawn. So if you do decide to buy an aluminum smelter, Remember the three things that actually determine whether you succeed or become the next Hawesville. The first thing is that you are not in the metals business. You are in the frozen electricity business. Every decision you make should flow downstream from that fact. When you evaluate a plant, you do not start with the LME aluminum price. You start with the utilities rate schedule and the contract length remaining on the plant's PPA. The second thing is that your power purchase agreement is the core asset, not the pot lines, not the port, not the customer relationships, not the brand, the contract. When that contract has 5 years left, your plant is worth roughly what it earns in those 5 years. 25 years left, and it is worth 10 times as much. The physical asset barely enters into the valuation. The paper does. Every buyer, every seller, every banker who is actually competent in this space knows this by heart. The third thing is that the day your contract expires is the day this business resets, and the utility has every incentive in the world not to renew you on the old terms. It does not matter that you employ 800 people. It does not matter that you supply the military. It does not matter that you have run continuously for 50 years. The utility answers to its own shareholders and ratepayers, not to your workers, your customers, or your legacy. It will do the math that makes it the most money. And in almost every case in the developed world since 2015, that math points away from renewing legacy smelter contracts at legacy smelter rates, which is why the United States now imports the majority of its aluminum. And why China, with its guaranteed coal-fired power, produces roughly 60% of the world's supply. That is not because Chinese engineers are better. It is not because Chinese labor is cheaper in any meaningful way. It is because the Chinese state underwrites the electricity. Forever. American utilities do not. European utilities do not. And so American and European smelters, one by one, contract by contract, quietly go dark. Every plant in the country you drove past on the interstate as a kid, glowing red in the night behind the tree line, is now negotiating for its life every few years. And most of them will lose. Not because they built the wrong pot lines, not because they hired the wrong managers, because they were never really metals businesses to begin with. Think back to that image at the beginning. The pot lines glowing red hot. $5 billion of capital. 500,000 tons of aluminum a year. Ships bound for Asia and Europe. Every single one of those glowing cells, 24 hours a day, is running on borrowed electricity. Borrowed from a utility that can, and eventually will, ask for its terms back. The metal is just the receipt for a long-term electricity purchase, converted into a form you can ship, stack, and sell on a commodity exchange. When the utility is generous, the receipt is worth a fortune. When the utility is done being generous, the receipt is worth almost nothing, and the plant printing it is worth even less. That is why aluminum smelters can be, in the same decade, some of the most profitable heavy industrial assets on Earth and some of the most catastrophic capital losses ever recorded. Same equipment, same workers, same product, different contract. That is the entire spread between print money and permanent ruin, sitting in a stack of legal paperwork. The building is not really the business. The contract behind the building is. That is the whole industry, from Iceland to Kentucky to the Persian Gulf, in one line. You do not own the smelter. You lease the electricity that keeps it warm. And the day that lease ends, so does the business, no matter how much aluminum sits in the yard.